Hello all. In the previous video, we discussed about constructors in Java. How to define a constructor, how to use it, and we also discussed about overloaded constructors in Java, right? So in this particular video, we will talk about the role of superclass constructors when you create an object, okay? Yeah, before discussing about that, we will recap what happens during object creation, okay? Now let's say you have a snowboard class, okay, and when you are trying to create an object by using new keyword, new snowboard of, what happens? So what happens when you do new snowboard of, Java first it goes and checks what are all the instance variables that are present in that particular class, and it allocates memory for those variables on the heap. Like let's say if it is an integer, it allocates 4 bytes. If it's a reference variable, it stores the address of the reference, right? So this is what happens. Like when you create an object, Java allocates the memory for these 3 variables, okay? That is our assumption. But actually what happens is, like let's here, snowboard is not extending any class. Snowboard does not have any parent. But in Java, object is the superclass of all classes in Java. Though you don't specify extends keyword like snowboard extends object, by default it is assumed that object class is the parent of the snowboard class. So, but let's say your snowboard class is extending a class called X, okay? In this case what happens is snowboard's parent is X and X parent is object, okay? So object in the hierarchy, object comes first and then the other classes will follow, okay? Now here, if from this diagram what we understood is snowboard's parent is the object, okay? So when you create an object like new snowboard of, not just like Java does not allocate memory not just for these 3 variables like X, Y, Z, foo X, foo Y and in Z. It allocates memory for these variables as well, okay? Now if you consider this example, what it does is first it goes to the X class and it finds what is the parent of X class. Since it did not define any parent class for X, it assumes that parent of the X is object. It goes to the object class. So it allocates memory for the instance variables that are present in the object class, and then it comes down and then it allocates memory for the variables that are present in the X, and then it comes down and then it allocates memory for the variables that are present in snowboard, okay? So first what it does is it will form a hierarchy, or it will go one level up till it reaches the topmost object class, and then it keeps on allocating the memory for the instance variables. Here if you see, first it allocated memory for the variables that are present in the object A, B, C, okay? And then it comes down to the class, and in the snowboard it comes down to the class snowboard, and in the snowboard class you can see 3 variables, right? X, Y, Z, and it allocated memory for X, Y, Z. Why is that so? Let's suppose we already discussed about the inheritance concept in the previous videos, right? So in the inheritance, let's say if your class is extending any of the parent class, you tend to use the methods that are present in parent class as well. Like now if you say I create a snowboard equal to new snowboard of, let's say I create new snowboard of, and using that object I can use toString of snowboard object dot toString of. I can use that because my snowboard is extending the object class, and I can use the public methods that are present in the parent class using the snowboard object, okay? Now let's say you did not allocate memory for these. When you do snowboard equal to new snowboard of, you did not allocate memory for the variables that are present in the object. You allocate memory only for these 3 variables. And you try to invoke snowboard.toString of method, okay? When you do that, in this toString of method, it can have logic related to these variables. Like in the toString of method, let's say it can print ABC, okay? Let me show that. Now in the two string of method, what I can do is, maybe I can put system.out.println of, and then I can print x y ABC. Okay, I can do that, b plus c. Okay, this logic would have been there in the two string of method. Okay, this logic I would have put in the two string of method. This is just for this is just example. Okay, this logic can be there. Now when I create a snowboard object and I invoke two string of method, the logic in the two string of method is system.out.println of b plus c. Now you are using b plus c and you did not allocate, you don't know where those variables exist. You did not allocate memory for that object. These variables has to live somewhere, then only you would be able to use those variable values, right? So you will run in, like, definitely you will get an error. So this is the reason why when you allocate, like when you create an object, Java does not just allocate memory for the variables that are present in its own class. It allocates memory for the variables that are present in its parent classes as well. Okay. Yeah, this is what happens during the object creation. Now let's come back to the superclass constructors. Okay, we all know, like, what is the constructor. Whenever you do new object of, then you are actually invoking the constructor. Let's say here, what I am doing here, I am using new hippo of. Okay, so new hippo of is nothing but you are invoking the constructor, and in the constructor you set the state of the variables that are present in the hippo object. That's what you do in the constructor. Like, let's say you consider an animal class. Okay, and then you have this hippo. Usually animals, during creation itself, you should set the size of the animal. That we already discussed in the previous video. During the creation itself, you should set the size of the animal. It's not that you provide set size of method and then you don't specify the size, because if you compare with the real world, what happens is you don't see any animal with zero size when an animal is born. It has some size, though it is very small, it has some size. So these are the examples where you need to specify the state of the object, at least few variables values during creation itself. Okay, now coming to the superclass constructors, whenever you create an object, what we assume is, let's say what I am doing here, I am going and creating new hippo of. Okay, now I go to the hippo of. Let me remove all these things. Now I go to the hippo of. Okay, yeah, if you see hippo of here, what's happening, it is extending the animal. Oh, it is extending the animal. What we assume here, by just looking at the new hippo of, we assume that, okay, the constructor that is present in the hippo class gets invoked. Here I am not specifying any constructor, but Java, we all know that Java provides you a default constructor. We assume that only the constructor that is present in hippo gets invoked. Okay, but actually what Java does is, in addition to invoking the constructor that is present in its own class, it goes to its superclasses as well and it invokes the constructors present in that classes as well. We all know that every class has a constructor, though you don't specify it, Java creates one for you, right? So when you when you create an object, how memory gets allocated for the superclass variables, when you create an object, not just the constructor that is present in its own class, Java goes to the superclass and it invokes the constructors that are present in those superclasses. Here you have the animal, right? Let's say I don't do anything here. I don't do anything. What happens is, hippo, I did not specify any constructor here, right? So by default what Java does is it plugs in your default constructor and it goes to the animal. And when it goes to the animal, what it does, it also will have some default constructor. Either you specify a constructor or it also has some default constructor. Then Java invokes the constructor that is present in superclass as well. Now since animal is not extending anything, it is assumed that it extends object. It goes to the object class and then it invokes the constructor in the object. So I can explain that with the help of this diagram. Okay, now if you see here, when you create hippo object, okay, hippo is an animal. hippo is an object, like animal class is extending object and hippo class is extending the animal. Now when you create an object, we know that the way it allocates memory for the variables that are present in object class, animal class and hippo class. The same thing you can see it here. Hippo is there, and in the hippo you have xy, and in the animal you have ksv, and in the object you have these three things. Now coming to the constructor, what happens is, first if you from in this diagram, if you see, first when you do new hippo of, it goes, okay, it goes to the hippo class and it sees, is it extending any other class or not. Then you find that, okay, it is extending the animal. Okay, like as soon as you do new hippo of, in the stack it will push the hippo constructor. Okay, it will push the hippo constructor, and after pushing the hippo constructor, what it does is it goes to the animal, because hippo is extending the animal, and then what it does is it pushes the animal constructor also on the heap. Now if you see on the stack, initially when you do new hippo of, hippo constructor is pushed to the hippo constructor logic is pushed to the stack, and then since hippo is extending animal, it goes to the animal class, and when it goes to the animal class, it pushes the animal class onto the stack. Okay, now after going to the animal, it sees whether it is extending any other class or not. Now you don't find that it is extending any other class, so Java assumes that since it is not extending any class, by default we can consider that object class is the parent of the animal. Okay, then what it does is it goes to the object class, and then it pushes the object of constructor onto the stack. Okay, now if you see the stack, last in first out, so last for at the bottom, to the bottom you have hippo constructor, and then on top of that you have animal, and then object of. Now object is the superclass of all classes. Then what it does is it starts executing the logic that is present in the object of. So while getting out of the stack, it executes the logic that is present in object of constructors. Okay, so when you do new hippo of, constructor gets pushed and then it goes to the parent class. Whenever you are pushing the constructor onto the stack, it just gets pushed and it goes to the parent class. Logic won't get executed. When it is coming out of the stack, whatever the logic that is present in the constructor gets executed. So if you see here, when it reaches the object and it don't find any other superclass, it wants to come out. While coming out, it executes the logic that is present in the object of constructor, and then once that is done, animal of is there, so it also comes out of the stack. While coming out of the stack, whatever logic that is present in the animal of constructor gets executed. Okay, finally hippo is present. Now while hippo is popping out from the stack, it executes the logic that is present in the hippo of constructor. So if you see carefully here, what is happening is, whenever you create an object new hippo of, first it goes to its parent, and then it has another parent. Okay, and it don't find any other parent classes. Whatever logic that is present in this constructor gets executed, then comes animal logic, and then comes the hippo logic. This is the order it follows. Then we might wonder, why are we doing this? I am just creating the hippo of object. What is the need? Like for allocating the memory, we understood the logic why to allocate memory, because we will be using the parent class methods as well, and those methods might depend on the state of these variables. Like toString of will depend on the BC, and if you don't allocate memory, then you will definitely get an error. Now in the same thing for the constructors, why are we invoking the superclass constructors when I'm just creating an object for hippo, for the child class? Okay, now it's the same logic. Okay, if you don't like here, you just allocated the memory, but if you don't assign any state, be it default values as well, if you don't assign any state, how the child class works? So that means, let's say you have the same situation you can consider here. You have ABC variables here and you have two string of. Like if you don't, the state gets assigned to the variables during the object creation itself, right? Though you don't specify anything, at least default values will get specified in the default constructor, like null, 0, 0. These also has to be specified. This happens during the construction part. So you say that during the constructor you either assign the default values if you don't provide any no arc constructor or if you don't plug in any logic. Otherwise, if you have some logic, like let's say if you want to set the size of the animal by default to 10, something like that, you can put that logic as well. Okay. Now let's say you have this of A, B, C variables and you are invoking two string of and it is printing B plus C. When you don't invoke the constructor, B, C values, you don't have any default values. It will have, you don't have any default values. And when you directly try to print B plus C, it will give error. But if you invoke the constructor, like when you create an object, snowboard object, and when you invoke the superclass constructor, you will have BC values as 0, 0, something like that. And when you do snowboard.to string of, this will not give error and this logic works fine. Or in few cases, let's say in your constructor, you have some logic setting BC values as 10, 20, okay. And when you do to string of, it will print 30, okay. This logic also like you are setting the state or you are setting the values for the instance variables that are present in the BC class. So if you don't set it, when you create an object and when you directly invoke to string of method, this will throw error. If you set the state of the object, then you will not get error. And apart from that, let's say even like let's say snowboard, you have snowboard turn on shred of get air of. Let's say this get air of method is using it is dependent on maybe hash code of method, like get air of method is dependent on the hash code of method, this superclass, and hash code of method might be dependent on these variables. So for you, whatever the object you have created, it will have few methods and it might depend on the parent class methods or it might depend on the parent class variables as well. And even let's say if it depends on the hash code, and hash code will depend on the object variables, right? So to properly set this method turn or get air of will work only if you have properly set this hash code of, and this hash code of method will not give any error if these variables are set properly. And this setting you can do during the construction part. Like when you do this new snowboard of, you can invoke the superclass constructors and you can set the state of the superclass so that your methods, like your whatever the methods that are present in your class will work properly, or even if you are using your superclass methods will work properly. Okay. Now you understood the usage of superclass constructors, why to invoke the superclass constructors, but how to invoke. Now what we are doing is we understood like when you use the superclass constructors, what happens is your parent class, your superclass state is getting set properly, like your superclass instance variables are getting initialized properly. Okay, that is what happening in the superclass. So when you are setting the superclass variables, it means that you are forming the object. You have constructed animal object properly, or you have constructed object or this object properly. When you constructed these two objects properly, your hippo object also works, because your hippo is dependent on either methods that are present in hippo which are dependent on animal methods, or your hippo is directly dependent on the animal methods which in turn depends on the state of the animal. Okay. Now how to invoke it, because now I am just doing new hippo of. When I am just doing new hippo of, how the animal constructors get invoked. We know that, let's say here if you see the main class, I am doing new hippo of. Okay, we all know when you do new hippo of, this particular line when you run, constructor that is present in the hippo class gets invoked, that we are aware of. But how to invoke the constructors that are present in the animal class? We don't know, right? So that we can do by using this super keyword. Now let's say here what Java, like if you see public animal hippo of, then what I can do is super of. Here if you see, whenever in the main class, when you're creating the hippo of object, it goes to the hippo class and it will execute this method, and in this method I'm calling the super of. When I call super of, what it does is it will go and searches for the class that is present after the extends keyword. After the extend keywords you have the animal, and then it will go to the animal, and whatever the constructor that is present in the animal, that logic gets executed, and then it comes back, and below if there is any logic it gets executed, but since there is no other logic it comes out of this constructor. Okay, now I can't use this like animal of, okay, it will throw error. You have to use super of to invoke the superclass constructor. Okay, now let's say I remove this. This also works fine. It is not throwing any error. Okay, now let's say in the main method I am creating an object for new hippo of, but in the hippo I am not saying, okay, I am not saying explicitly to invoke the animal constructor. When you do new hippo of, you know that even if you don't specify constructor, Java plugs in a default constructor for you. But I did not mention anything about animal class. Okay, but still it did not throw any error. Why it did not throw error is how, like Java, how it is plugging in you a default constructor if you don't specify any constructor at all. What Java does is, in addition to the default constructor, it will insert a super also. Like if you see public animal of, then it will do super of. So this logic, like even if I don't specify any logic, this logic gets inserted. Okay, now when you don't specify any constructor logic, if it has super class, what Java does is it does super of. So Java does that for you. Okay, even if you don't specify, default constructor logic gets executed. Now since this logic will be plugged in by Java, it goes to the superclass. Here the superclass is animal, it goes to the animal, and we all know even in the animal what it does, it will do something like this, public animal of super of. It does something like that. Here why are we using super of? Because it will extend the object class, right? By even if you don't specify any extents, it will extend the object class. So this logic will be plugged in by Java. So that's why when you create an object, that we will see, okay, with an example. System.out.println of animal logic getting executed. Okay, now we will see in which order it comes. Animal logic getting executed, and in the hippo what I'll do is I'll do system.out.println of hippo logic getting executed. Hippo logic getting executed. If I do something like this, and let me run the main class. Son of Boo. Yeah. Yeah, I'm just commenting these things out. So if you see what had happened, first, okay, starting got printed, and then when you do new hippo of, it goes to the hippo class. Okay, it goes to the hippo constructor, default constructor, and it goes here, and then it goes to the super of. When you do super of animal, it goes to the animal logic, and then it goes to the animal logic. In the animal logic, it goes to the super of, but I guess nothing is there in the object. Nothing is getting printed from the object constructor. Okay. Then like the same thing, whatever we are showing, we have shown in this particular stack frame. First, hippo constructor goes to the stack, and then it pushes the animal constructor, and then it pushes the object. It came out of the object. While coming out of the object object logic, it executes the logic that is present in the object constructor, and then it executes while popping out the animal constructor, it executes the logic that is present in the animal constructor. Okay. Now the same thing had happened here. It goes to the animal, it invokes the super of, and then it prints this animal logic getting executed. That's why you can see first statement animal logic getting executed. Then nothing is there. Then this particular animal of will get popped out. It gets popped out from the stack, and then it goes to the hippo, and in the hippo it already executed its super of, because of which you can see this animal logic getting executed. And then what it does is it prints hippo logic getting executed. Okay, this is what, as we said in the, like if you see this constructor, a chaining reaction happens. First logic present in the first superclass gets executed, then animal, then hippo. The same thing you can see here. First animal logic, then hippo logic. Now I said you right that even if you don't specify super of, Java does that for you. Let me show that with an example. I remove this super of. I'll remove this super of and see what gets printed now. Like now what happened, I removed this super of. Then how it will invoke the constructor, superclass constructor. Let's see. I print this, I just ran the class. Now if you see the same lines got printed, animal logic getting executed, hippo logic getting executed, because I said you right, even if you don't specify anything, Java at the first one, like for the first line, in the first line of the constructor, it inserts this line. Okay, because of it went to the animal constructor, and then it executed that logic. So Java does that for you by default. Okay, even if you don't specify anything, it will invoke super of. Okay, and one more thing, this super of has to be the first line. Why it has to be the first line? Because here first object logic should get executed, animal logic should get executed, and hippo logic should get executed. It's not the vice versa. So you might think that okay, let us run first the system.out.println and then I'll run this super of. No, you should not do that. Java throws you error if you do that. Let's say, if you do this super of, then Java throws you error. You should not do. Why? Because see here, assume that these are the parents and these are the children. Like if you really think in general, parent exists before the child even comes, right? So first parent state has to set properly, or parent instance variables has to be initialized. Later on, then only you will be able to initialize the child class variables. Now I'll explain with an example. Okay, let's say I put something called size here, hippo size. And for this hippo size, what I want is, I want to add +1 to the animal size. Okay, like for hippo I'll add here, if you see, what I'll do is hippo size equal to maybe size +1. Okay, so how that happens is animal size +1. Okay, now if you see here, this is the animal, and here also I'll have this animal size. Okay, private int size I'm declaring this, and here I'll have some method public int get size of. Okay, and I'll do this get size of, return this dot size. Now in this constructor hippo, what I will do in the constructor, I'll do size of, get size of +1. Okay, I can do this. Okay, get size of +1. Now first here what I am doing, my child class hippo class is dependent on get size of, and this get size of is there in the animal class, and this get size of is dependent on this size variable. Okay, now if you run, let's say now first animal constructor gets executed first. So while it is executing the animal constructor, maybe this will put this dot size equal to 10. Okay, now when it first executes the animal constructor, by the time it comes here, it will have the get size as value 10. Okay, and it will work fine. But instead of that, if you run hippo logic first, you are running the child class first, and your child class is dependent on the parent method, and your parent method is dependent on the instance variable present in the parent. Now this will throw error, right? Because get size of method for the get size of method to give the output, this dot size should get initialized, be it 0. That initialization did not happen, and you are directly directly running the hippo method, and you are dependent on the parent method, and your parent method is dependent on the parent state. Without setting the parent state, you are trying to invoke this. This is not the proper flow. That's why when you, like, if you don't specify any super of, what Java does is it does like this. It will invoke super of, it will go here, and it will then set the size, and it comes here, and you will have this get size of method works properly. But if you do something like this, super of, Java will give you a error saying super of should not get initialized after. Okay, call to super of must be first statement in the constructor body, because parent state should be set first, then only children state should be set. Like, parents come first to the world, then only children comes, right? It's not that children comes later on parent come. So this is the reason why the first parent constructor gets invoked, and then only children constructor gets invoked. Okay, that is the logic you can see. Now to invoke anyway, even if you don't specify anything, Java does that for you. Like, it by default it assumes it inserts the super of, and your parent constructor gets invoked. And let's say here you saw, right, super of, here you're setting the default size as 10, but you don't want that. I want to take this size from the user itself. Okay, something like that, new hippo of 10. Okay, now here if you see, it goes to the hippo, and then let us assume that int size. Okay, int size. Now to set, what you can do is you can do this in super of size. In the animal, what you can do is you can put this in size. Okay, so what you are doing here is basically you have a parameterized superclass constructor, and to invoke that parameterized superclass constructor, you are you are passing the arguments. If you don't do this, okay, you will get an error, because we all know that super of should be the first statement in the constructor, and if you don't specify any constructor, Java does like this, super of, and you don't see any default constructor in the animal class. In the animal class, you don't have any default constructor, then it will throw error. Okay, if you want to use any parameterized constructor, superclass constructor, it is your duty to specify as a first line in the constructor. Otherwise, what it assumes is, let's say it assumes that it will super of should get it assumes that I should insert super of, and I don't see any default constructor here. We all know, right? If you don't specify any constructor at all, then Java plugs in your default constructor. But if you specify at least one constructor, Java will not plug in your default constructor for you. Now let's say I specify this public animal of, I am not doing any logic. Now this will not throw any error, because what happens is it assumes that, okay, the person, whoever is coding, did not specify any super of, I'll do that for them. Okay, it does that, and it finds the default constructor, and this logic gets executed. Okay, this logic gets executed, and it works fine. Okay, now what we understood what is the role of the superclass constructor, and why do we even need to invoke that, and we also discussed about the order in which the superclass constructors gets executed. Okay, now we understood if you don't plug in any constructor, Java does super of for you, and if you want to use any parameterized constructor, then you have to use this super of. Okay, and there is one more use case also where where this constructors has to be invoked first. Let's say you have this animal, okay, and then you have this private int name, or maybe you can take the size only. Okay, you can take just size, and then in the hippo what is happening is, in the hippo you are dependent on the size you are dependent on the size of the animal. You are dependent on the size of the animal, and this is also one of the use case why the superclass constructor has to be invoked. Okay, now coming to the overloaded constructors, we discussed in the previous video that overloaded constructors, let's say this is one method, and this, let's say I can declare new hippo of, and I can set this dot hippo size equal to 10. Okay, this dot hippo size equal to 10, but in each and every method, okay, I need to pass name. Let's say what I'll do is I'll declare one more variable called string name. Okay, and then what I'll do is string name. Okay, string name, and then I'll set the size of the name of the animal. While creation itself, I'll set the name of the animal. This dot name equal to name. Okay, this dot name. Now if you see the logic here, what I have done in this variable, in this particular constructor, I am setting the size and name, and in this constructor I am setting just the name. If you look, this particular code is duplicated. Like you are executing the same logic here as well and same logic here as well, right? Now let's say from the hippo, if someone calls you, okay, I'll just give them the string name. Okay. So what you will do is super of size comma name. Okay, this will work fine. And then let's say they just want to set the name as well. What you will do is you will do super of name. Super of name. Okay, now if you see here, what you are doing, whenever a person comes and they are creating the hippo object, and if they want the default size, then they can just specify the name. Okay, here we are setting the default size, but if they are specifying some size, what you can do is int size, and you can accept the name. Now what happens, you don't have any name variable here. Here if you see, animal is the superclass and animal itself has the name variable. Okay, now to set the name, now how to set this name variable? Now you don't have any set name of, the only way to set the name of this particular animal class is, because you can't even create an object for animal because it's an abstract class, and your hippo method, let's say your hippo method wants to print name. Okay, your hippo method wants to print get name of. Okay, I can just do this animal public string get name of. I can just invoke return this dot name. Okay, now if you see here, I am doing this as well, system dot println of dot get name of. So here you want to set the name of the animal. Okay, name of the animal, but you don't have any setter method in the animal. You don't have any setter method, you just have the getter method, and you can't even create an object for animal class because it is an abstract class, and the only way to, and your hippo class is dependent on, get name of method. Okay, now without setting the name, if you invoke the get name of, it will definitely fail, and the only way to set name of the variable that is present in superclass is via the constructor. So when you create an object for new hippo of, you can invoke your superclass constructor, and in your superclass constructor you can set the name, right? This is one more advantage of the superclass constructor. Okay, now let's say we already spoke about the duplicate code here, right? Here what we are doing, a user either they can specify the size or they can take the default size as well, but they have to specify the name. Okay, they are specifying the name. Now when they are specifying the name, what I am doing is, when they specify both size and name, I am doing super of size name, and when they specify name, I am just calling the super of name. Okay, now if you go here to the animal class, setting the name is same. Like you get the name and you just set this dot name equal to name and this dot name equal to name. So it's a duplicate code. This is just one line of code. It should be fine. But you might have another complex logic where setting some value, or let's say for setting the not the name, let's say you have another instance variable for which while setting the value you should have some logic. Okay, maybe private in some random value, and this random value might be dependent on some custom code logic. Okay, now you might write that custom code logic here. Okay, and you might write that custom code logic here. Then it's like a duplicate code, right? To avoid that, what you can do is, here if you say this dot name equal to name, now anyway you have to set the name, and that is happening here. Why can't you invoke another overloaded constructor directly from here? If you do this, this will fail, definitely fail. Animal, what I want is, I have name, I don't want any duplicate logic. That's why I am invoking the already another constructor. Like invoking, these are all the overloaded constructors, invoking one constructor from another constructor to avoid the duplicate logic. Now this will fail. So to invoke the constructor, what you have to use, you have to use this of. Okay, if you do this of name, okay, this of name, you have to do this dot name, and then you can do this will work fine. So this way what you understood is, here this dot name equal to name, this particular line is already present here. I am just using that. Let's say if I put some 20 lines of code here, then if I do this dot of name, all the 20 lines of code gets executed here. I need not copy here. I need not copy everything here. Okay, now when you do this of, can you do the super of? No, you can't do it. So the rules that are present in Java is, your first statement in the constructor is to the super of. That super call can be argumented, or like you can have parameters that gets passed, or it is a no or anything. Like either I can do it. So if you go here, this super of you have, right? Either you can put super of size of name, or you can just put super of also. This also will work perfectly fine. So we all know that the first call, the first line that should be present in the constructor is to the super of, or you can also have this of as well. Okay, now why I am saying this of is, here if you say, let's say I remove this. Okay, get printer, here we are already setting the name of. Now what I can do is, I can do this of name. Okay, now what happens is, here I am not using any super. If you see here, user what they does is, what they does is, they will set the size and name. Okay, size and name test. Okay. And in your hippo class, what you are doing, you are calling this of name. When you call this of name, what it does is, it goes here and then it invokes the superclass constructor and it comes back, and then it will print the get name of, and then this logic gets executed. Okay, this of name. So like when you have a overloaded constructors, or when you want to, like you can have multiple constructors, right? Multiple constructors which varies only in the number of arguments, and all those constructors might have the duplicate logic. What you can do is, you can put all the duplicate logic, you can extract out the duplicate logic and you can put in a single constructor, and you can invoke this constructor by using this of, okay, from another constructor. So like let's say, even if you create another constructor which varies in arguments, what you can do is, you can first call this of name, and this constructor gets invoked, and this constructor will call your superclass constructor. Okay, so the first line in your constructor should be either it should be this off or super off, and in the this off anyway you will call super off. So like our main thing is, whenever you run the constructor, first the superclass constructor should get invoked, and then only the child class constructors. Then only the state of the objects will be set properly. And even if you are using the, now let's say even if you are using this off, it goes here and it will call the super off. So super off is getting called for the first time, so you don't have any issues. The only thing you have to remember here is how many overloaded constructors you write. Our first call should be to the super off, and even if you are using overloaded constructors, then your first call should be this off. Okay, yeah. So what we to summarize what we have discussed is, first we understood when you create an object, it will not allocate memory just for the variables that are present in its own class. It will allocate memory for the variables that are present in the super classes as well. And when you run a constructor, first it runs the superclass constructor and then it comes to its own constructor. Okay, now the way to call the superclass constructor is using super off. Super off can be without arguments or with arguments. Even if you don't specify any constructor, by default Java does that for you. It will create a default constructor, and inside the default constructor you will have super off. And even if you are writing your own constructor and if you don't specify super off, Java does that for you. Okay. And when you want to avoid the duplicate logic, you can extract out all the duplicate logic and put in a constructor, and you can invoke this constructor from another constructor using the this off. The first line that should be present in the constructors is either this off or super off. Okay, and since parents exist before child, first parent state has to be set properly, then only the child state will be set. Okay. Hope we understood, we discussed clearly about the superclass constructors. Thank you.